In this video, we will talk about Ghidra, which is a decompiler tool. We will talk about the method for improving the C code output from Ghidra. Ghidra is a decompiler tool that recently open sourced by the NSA. It's a very comprehensive tool that supports wide range of processor from 8-bit to 64-bit, and it supports a wide range of file formats for binaries. So for security analysis and reverse engineering from binary to C source code, this is a very good tool. But the C code output from Ghidra is not always friendly in terms of readability and usability. There are two kinds of binary code that typically people supply. One is unstripped binary. Unstripped binary contains symbols information such as functions or variable names, data types, and so on. The stripped binary, however, does not contain symbolic information, and typically third-party production binary code are stripped binary. C code that are output by Ghidra for both cases can be improved. And the demo will talk about the methods how to do that. It make use of samples of source code or versions of source code, and it also use the features in Ghidra to improve the C code output to make it more readable. So it will talk about the unstripped binary. So unstripped binaries for output from Ghidra tend to have problem with complex data types and function names. Sometimes they have the name that readable, sometimes not. And parameters, sometimes passing in and out has extra parameters in it. But unstripped binary is easier than stripped binary. So we will spend more time on a demo to talk about the stripped binary method. The techniques for stripped binary will also apply to the unstripped binary. So in this demo, mostly we use manual method, and we will follow with another video to discuss automation of these techniques. So the demo and the discussion will be followed.
This is the main Ghidra window, and in this window they have the assembly we've taken from the decompiled binary. And in this window we have the C code taken from the assembly. In the data type manager we have the symbols that we've taken from the binary as well. And in the symbol tree we have the different functions, labels, classes, and namespaces of the program. This is the unstripped binary, so we can see that they've managed to recover the function names. However, they've changed the return type and the variable types and names of the functions. The original source code is a simple quicksort program, and as we can see, the main function used to have an array of 6 integers, which has been changed to separate undefined variables. In the stripped binary, the function names have not been recovered, so they've been auto-generated instead, but they still have the function bodies. In either case, the code isn't very readable to the user, but Ghidra has tools to allow us to make the code more readable. Looking through the functions in the symbol tree, I can see that this looks like it might be the swap subroutine, so I'm going to name this swap. And the parameters were originally integer pointers, so we'll change those as well. And looking at the original source code, the decompiled code and the source now match. I'm going to commit the parameters and the return type to ensure that the changes are reflected across the entire program. I'm going to work my way upwards, starting from functions that don't call any other functions, and work my way upwards through the program. I'm going to use the references that each location makes to find which locations make a reference to swap. And this function calls swap both times. And according to the source code, this function was originally partition. So I'm going to rename this partition. I can continue on fixing the code manually, but I can also parse the header files and the source files for the program. Here I'm using the quicksort header, which prototypes the functions. These are their names and their parameter names and types. If I look in the data type manager, the quicksort header is now here, and the functions are included. I'm going to apply the function data types. And now the return type and the parameters have been fixed. I'm going to go upwards again. And according to the source code, this should be quicksort. In addition to parsing the header files, I can also parse the source code as well. So I'm not going to use the entire source code, but the quicksort f.c contains the quicksort function itself.
So you only use samples of the source code instead of the entire source code.
Yes. And now quicksort is fixed as well.
With all the original names for variables and types and everything.
Yeah. The local variables, they would still need to be changed manually if you want them to be exact. But for now, it matches, the basic algorithm matches that of the function, and the parameters and the variable types match.
Okay, so it's very readable at this point.
Yes. Now this should be the main function, but before I fix that, I'm going to go to the print array function. So now the parameters for print array are fixed. And Ghidra makes a change to the printf call where the second parameter is cast into an unsigned long. But for now, I'm going to go back to the main function. Now the main function isn't included in the header, but I've included it separately in a C file. And here's where it's defined. So now that I've applied the data types again, the return type for main is fixed, but I still need to fix the local variables in the body of the function. As I've said before, the array originally in main has been changed to an undefined variable. So now I have to retype the first element of the array. This was originally a 6-element array. And now it's an array again. And Ghidra has added some extra variables, such as variable 1, offset, and this if statement right here, which is not part of the original program. But overall, the code is now much more readable. In summary, I went over the issues that Ghidra presents with both the stripped and unstripped binary, and I've gone over how to manually fix the stripped binary and how to use the C source parsing tool to accelerate the process. The steps taken manually can also be recreated as an automated script for examples that the user doesn't have to do everything manually. That can be covered in a later video.